whenever we build a model or a blueprint, it helps to understand the complexity of the problem. Okay, and they can be used for various kinds of phases during the software development process, like analysis, specification, implementation. That means during the coding phase, designing of the system. Okay, preparing or understanding the problem in depth and how the system works. Okay, and also in the testing phase. So that is the reason it is very much important that you make a model, and UML is one of the most important, you can say, modeling prototypes. Okay, so in all these applications, the UML models can not only be used to document the results, but also to arrive at the results themselves. So making these UMLs, actually, you will be able to not only be able to know uh, just to document how things work in the system, but also you'll be knowing what kind of different outputs it is expected at various phases. Okay, so modeling serves variety of purposes. Okay, so it is expected that the model choice would change depending upon the reason that is being made. Okay, for example, some models may be made only for analysis phase, specification phases. Okay, some models may be used only for the design phase. Some model may be used for taking certain decisions. Okay, so it depends actually from I mean to say, the phases of the development that you are making. So accordingly, things will be different. So first of all, what is UML? UML is actually a modeling language. That means it is a method through which we can prepare a blueprint of the software. Okay. So using a UML, UML first, the full form is Unified Modeling Language. Okay. So UML helps us to visualize, it helps us to specify, it helps us to make, and also it helps us to document the requirements of the software system. But we cannot just make UML. Like in case of DFD, we have to know certain figures, certain diagrams, isn't it? We need to know. So similarly, in UML also we need to know certain notations. Okay, so notations can be lines, notation can be rectangles, notation can be ellipses. Okay, depending upon the different kind of entities that will be there. So UML also has its own syntax, that means symbols and sentence formation rules. Like in case of DFD, we remembered, if you remember, the process name should be a verb and the name of the external entity should be a noun in DFD, if you remember. So similarly, in UML also, it has its own grammar. Like there are certain symbols, we have to know there are certain rules during which we have to follow while framing a sentence. There are certain semantics also uh, linking to symbols and sentence. So every symbol and every sentence will have a meaning. That means there will be a semantic. So those things we have to know. So we need to know that UML, Unified Modeling Language, is not a system design or development technology, but it can be used to document object-oriented and analysis results, okay, using certain methods. So UML is basically used if you're doing a project in Android development, okay, when you are building mobile application app. Okay, then that time you can represent the problem with the help of UML. That time you don't need a DFD, or even if you need a DFD, but mostly the proliferation, the work has to be defined using UML. Okay, so that's why if suppose someone are interested to go in a mobile application development, then they are to know UML very nicely. Okay, so let us see first how did UML came into picture. So in the late 1980s and early 90s, okay, there was so much of demand of object-oriented design techniques and notations. Okay, so different people were using different notations. Okay, to document this, that means to write down the reports for the object-oriented design. Okay, so this created a lot of confusion because every people were using their own notations. Okay, so that created a lot of confusion. So to overcome this kind of problems, what happened? UML was standardized. Okay, UML was standardized using various kinds of notation, and it was used extensively in the early 90s. Okay, So these UMLs were standardized by various people, by various people involved in developing systems. So one was Rambach. So in his book Object Management Technology, he defined actually what is UML, what are the notations you should use. Grady Booch again came up. Okay. So these people, Jacobson, Odell Scheller, in the early 90s era, they basically came up with a concrete notation. Otherwise, in the early phase, what was happening? Everyone was using different notations. They were using different meanings. So hence, they created a lot of confusion. Okay, so this thing was there. So no doubt UML has borrowed concepts from other modeling techniques also. Okay, but UML is something which will remain, and that's why this has been there till now. Okay, so UML is now being used in a large scale in a large number of software development projects. Actually, students should be joining on like by 10:05. Okay, anyways, so let us see the diagram. So UML can be used to construct 9 different types of diagrams to capture different views of a system. So a software, when you build, there are many views, there are many approach, there are many perspectives. It is the layman's perspective, user's perspective. It is the structure, the how the software has to be built. Okay, like classes, objects which are interrelated with a particular system. It is with respect to behavioral, with respect to implementational, with respect to environmental. Okay. So depending upon various perspectives, various views. Okay. So accordingly, the UML diagram captured different views of a system, of a software. Okay, like user view. So in user view, basically it will show how the software will behave with respect to different users. Like in data flow diagram, the approach was shown from the external entity point of view, isn't it? So, yeah. But here it's the same thing only. Here also it will be seeing the whole use case diagram from the one who will be using the system or the app. Are you getting? So that is the user's view. Structural view is basically what are the various classes, objects that can be there, which can be uh, there while making the system. So that will basically be described in the structural view. Then in behavioral view, it will show the various states, the various phases that is there in the while making the software, the various sequences that may be there, the various collaborations that the objects can be there, the various activities that can take place. So all those things will be captured in behavioral view. In implementational view, basically like how things are being implemented. So that is shown with a diagram called component diagram. Then environmental view basically will give you an idea of where the software is being deployed, who will be the users. Okay, all those things will be shown in environmental view. So likewise, so if you see here, there are 5 different views, isn't it? User view, the central part, then the structural, behavioral, environmental, and implementation. The user's view is being represented by use case diagram. Structural view is represented by class diagram, object diagram. Behavioral view is represented by sequence diagram, collaboration diagram, okay, and others. Environmental view, okay, by deployment, DFD, implementation view by component diagram, okay. So these are the different types of diagrams. So these are very important for exams also. So when we talk about the user view, this view actually defines the functions, the facilities that are there in the system. Okay, so the user view, basically you have to think from the external user's point of view in terms of what are the facilities or functions that the system will have. Okay, what are like it can have, suppose if you have a library management system. So there, what are the things you may have? The functions like create users, isn't it? Then add entry of new books, isn't it? So all those things will be the view which will the librarian will get to see while making all those functions work. Okay. So the user's view is just a black box view of the system, because in the user's view, it will only know what are the functions which are available in the system, but it will not know how these functions are being made. So coding is being hidden. Only through the interface of the system, you will be able to make use of the functions or the facilities that are there in the system. Okay. So the implementation details, okay, or the dynamic behavior that is taking place inside the system, it is not visible. The user's view is very much different from all other views, because here we are only getting the skeletal, or we are just seeing the interface, how things work and what are the facilities available for us. But it will not know how these facilities are being coded, okay, what are the packages which has been used, what are the data structures we have used while making the system. So all these information are hidden, okay. So that basically relates to mostly to the kind of a blueprint only, not a blueprint exactly, but basically the outer view which we can do it. Okay. Then next comes the structural view. So the structural view here basically defines the various classes that you have used, the various objects that you have used, okay, in implementing the system, or while implementing, before implementation also, if you can take certain decisions that these are the classes, these are the objects that you will be using, okay, for uh, building the system, the relationships between the classes and the objects, okay. So that can be defined in the structural view. In behavioral view, basically, it shows how objects basically interact with one another, how message passing is being done between one object with another. So it shows you the dynamic behavior of the system. Then implementation view captures other important components of the system, okay, like the data structures which are there, okay, the memory occupancy that is required, okay, and the dependencies to build the system. An environmental view basically shows the different uh, factors which are implemented on the hardware, okay, which is built on the hardware platform. So this is very important in query, like what is UML, this is asked only. Okay. Then we will enter into use case diagram. So in let us go for use case diagram. So let us take, there are various set of use cases. Okay. So use cases, as we said, that it is the various functions that is there in the system that can be showed with the help of a use case. Okay, so use case, again I'm saying, use case is nothing but the various functions or the facilities which are available in a system, in a particular app, in a particular software, that can be showed with the help of a use case. So let us, here they have taken an example of library information system. What can be the various use cases? Issue book. The librarian will issue a book. So this is a one use case. Query book. Okay. There can be a query, or there can be a check from the librarian side if this book is available or not in the software, isn't it? So we will use a use case called query book. Return book. If suppose someone has returned the book, or if suppose there is a due date for return a book, so that part will be taken by the use case return book. Create member. So suppose if existing student is already there, but new students when they come in. So we will use a use case called create member, add book. So if suppose new entries, new stock of books have come into the system, isn't it? So we need to update that in the software. So we will use a use case add book. If suppose the number of stocks, suppose one book is already available, okay, but the number of stocks has increased. That means same book has come from the publishing house. So that has to be entered again to the software. So we can have one more use case called update book. Okay, so basically in use case, what we will do, we will try to represent using a use case or a use case model by writing it down, the various functions that it can have. Okay, so use case basically shows us or leads us to the high level functional requirements. The use cases partition the system behavior into transactions. Okay, so every use case will divide the system behavior into transaction, like issue book will be one of it transaction. Okay, query book will be another transaction. It will do this, every use case will do separate kind of work. Okay, it is meant to do. Okay, and each of the work will have certain actions, meaningful actions, that doing that work, basically we will get certain kind of output. Okay, so to complete each transaction means if each of the use case has to be completed, okay, then it may involve either a single message or multiple message exchanges between the user and the system to complete. So if suppose I'm making use of issue book, okay, so what message should be given by the librarian for issue book? What message? The book name and the person to whom the book has been issued, isn't it? So that way, if suppose query book, I want to make use of this use case query book. So what message I will give to this use case query book? I have to give the book title, book ID, name, and accordingly, whatever if it is available in the library, so the software will check from the database and it will retrieve, or from the server, isn't it? So depending upon which use case I want to make use of it, accordingly I have to pass message. The message can be one message also. That means only one factor attribute I can pass, or it can be multiple attributes. Okay. So the main purpose of use case basically is to let us know the main behavior. Okay, we will only be knowing like what these use cases will be doing, what the parameters the use cases will be taking, but how the use cases are being implemented. That means what algorithm we are using, what programming language we are using, what packages we are using, what frameworks we are using. That it will not show. Okay, it will not show the internal implementation information. Okay, but it will give you the meaning that okay, this use case work is this, we have to supply this parameter, and accordingly the work will be done, but how it is being done, that is not being revealed. Okay, so a use case typically basically shows how the interaction takes place between the user and the system. Okay. Okay, so I think it's understandable. Okay, so that is what I. These are all theory actually. So how use cases are represented also can be represented by using a use case diagram and writing an accompanying text elaborating the diagram. Okay. In the use case diagram, each use case is represented by an ellipse with the name of the use case written inside the ellipses, and all the ellipses or the use cases of a system are enclosed within a rectangle which represents the boundary of the system. The name of the system being model, suppose this is the name of the system, appears inside the rectangle. We'll see with the example. First, let me read. The different users of the systems are represented by using a stick person icon. Each stick person icon is normally referred to as an actor. An actor is the role played by a user with respect to the system. Actor here means the users, okay? Like in DFT, we had the external entity. So here, actor in case of use case is the user. So it is possible that the same user may play the role of multiple actors. Each actor can participate in one or more use cases. So one user can make use of different use cases, okay? The line connecting the actor and the use case is called the communication relationship. It indicates that the actor makes use of the functionality provided by the user. Both the human users and the external systems can be represented by stick person icons. When a stick person icon represents, okay. Let us see. Yeah, let us see. Okay. Suppose so here, this is a system which is being built. It's very big file. Okay, so this is the okay. A supermarket needs to develop the software to encourage regular customers. For this, the customer needs to supply his or her residence address, telephone number, and the driving license. Registration that is being done by the customer. Each customer who registers for the scheme is assigned a unique customer number. So once this is done, like basically in Reliance retail or maybe in Vishal Megamart or Big Bazaar also same thing. No, we have to do registration and then they will give us a unique code. We have to give our phone number, all those things. Okay, so a customer can present his unique customer ID to check to the checkout staff when he makes any purchase. In this case, the value of the purchase is credited against his number. Okay, so here this credit system is also there. Like we can recharge the card in advance, and from there the money will be deducted. Okay. Okay, at the end of each year, the supermarket intends to award surprise gifts to 10 customers who makes the highest total purchase over the year. Okay, also it intends to award a 22 carat gold coin to every or customer who purchase exceeded rupees 10,000. Okay, so I think it is somehow relatable. So let's say we have this supermarket price scheme. This is the name of the software. So who are the actors? Customer will be very much there. Sales clerk will be there. Sales clerk and then manager. So customer is the actor. He will use there will be three use cases here. One use case is will be used for customer registration. One use case will be there for registering the sales volume of sales of product in one day. One use case will be there whose work only will be to select the winners from the registered customer. Okay. So if you look here, customer will make use of this use case. Okay. And then accordingly, actually customer will not do the registration, but he'll provide the information. Okay. So customer indirectly is making use, like if he doesn't give the information, will we be able to feed his data? No, right? So accordingly, when he'll give the information, okay, so he suppose out of all this, which of the use case will be more beneficial for a direct relationship? This is the link relationship. Okay, these lines. Okay, and the use cases whenever you make it is like this ellipsis form. Okay, and the name of the use cases we have to write inside the ellipsis. The use cases have no numbering, and the system, this is the system boundary. That means within this boundary only all the work has to be done. Okay, and this is the name of the system, supermarket scheme, as I'm saying. Okay, then so what now look here for here, suppose this is the register customer. So the clerk, whoever is managing, he will be getting all the information through this use case, whatever are the information of the customer. The next case is registration of the sales. That means the sales volume that is there. So accordingly, the sales clerk basically will keep track of how many number of sales has taken place, sales of product in that particular supermarket has taken place. So how will he be able to know? Because all those information will be stored in the system. So accordingly, he will make use of this register sales use case to get the information. Similarly, select winners. Now, select winners cannot be done by these actors. Customer also cannot do, sales clerk also cannot do. It is someone who is on a higher authoritative position That particular person only will be able to do it, isn't it? So who will do it? It is the manager. Okay, so we'll be making use of the select winners use case. Is it clear? So this is the use case model of supermarket price scheme. So see this again, you have to give the description here like this. The customer select register the customer option. Okay, system will display prompt to enter name, address, all these things. Like
So,
this is with
sir,
respect to first use case.
so like
Okay.
is like UML just the diagrams that will make like is there some code in it?
Yes.
No, like no code is there, just the diagrams.
No, no. Yes, only the diagram. This actually happens in the initial phase while designing the system. So when you are not sure about like what are the things you will be needing later, no, when you have not started the coding. So before coding only you have to make these diagrams so that you will be knowing what are the various features the system will offer.
Okay, sir.
So accordingly, once we have made the use case, then after that, what we will do, we will describe each of the use cases. Okay. So in that way, mainline sequence these things from this. These are easy. You can go through also on your own. These things I'll do in the next class. Because they are quite easy. This is a case example of generalization use case. You have heard about of the term specialization and generalization? Anyone? Have you heard about the term specialization and generalization?
So like generalized means like I mean like it's like used by everyone so that it's very common. I guess I mean just like loose meaning. I
No,
guess.
in DBMS, what do you mean by generalize and specialize? Anyone? Okay, then you just 1 second, huh? Okay, we will stop it. Okay, because